Ladies and gentlemen, thank you very much for joining us here today. We are living in truly revolutionary times. Machine learning and AI have well and truly graduated from research labs and are starting to transform our lives in ways that we still find it very difficult to foresee. Of course, in popular cultures, Siri and Alexa, translation apps, they're very much part of our lives now. But where that will go, we don't really know yet. There are, of course, also as many pessimists as there are optimists about where artificial intelligence will take us. There's the likes of Stephen Hawking and Elon Musk, for example, have been very vocal about this. And there are lots of questions about the future of the technology itself. There is one of the big questions out there is when will AI make that leap from being able to spot patterns in reams of data to what some people call common sense thinking. So I'm very excited about the panel that we have here today. To my right is Professor Jürgen Schmidhuber. He's Professor of AI at USI University. To his right is Andra Kay, the Managing Director at Silicon Valley Robotics. To her right, Pascal Kaufmann from StarMind. His website says he has been obsessed by robots, cyborgs, artificial intelligence, and brain research for years. To his right is Dr. Anna Ukanova from Google Research Europe. And we have Professor Thomas Hoffmann from Data Analytics Lab at ETH Zurich. So I thought it would be an interesting way to start out this panel by thinking a little bit about what exactly is machine learning. I think that's sort of the basis of a lot of the conversation we're going to have over the course of the next 90 minutes or so. And I'm going to start. So I'll start with the basics, and I'm going to start with you, Anna. There's a lot of preconceptions about what machine learning actually is. But can you tell us a little bit about how that works? How does a computer teach itself? And to use sort of a specific colorful example, how can a computer learn to tell the difference between, say, a cat and a dog?
Let me start with a definition of artificial intelligence. It's an art and science of making things smart. For me, it's not about building machines that are like humans. It's about building machines that are useful to humans. We've seen a lot of progression in this field in the recent years, and it's largely to a more narrow field that is called machine learning. Machine learning is teaching machines to recognize patterns by examples rather than programming it with specific rules. The software that learns is called neural networks, and it very loosely mimics human brain. It consists of millions or billions of neurons, where each neuron is just a tiny computational unit that can perform some mathematical computation and then pass the results to the connected neurons. When those neurons are combined all together, they create a neural network. And in deep learning, that's another very popular term, these neural networks are arranged in layers. And the layer of neural network can learn some complex patterns thanks to the computation information that is shared across those neurons. And then in deep learning, we have those layers that are arranged one on top of the other. And so each layer can learn the patterns from the layer below it. So in the end, it learns patterns of patterns of patterns. And so somewhere at the highest layers, neural network can grasp some of the more complicated concepts, such as what a hug is or how does a sunset look like. And if we would like to get a neural network to learn to recognize a cat, then we would show it thousands of examples of a cat. And every time when it tries to recognize what the content of the image is, and then, for example, mislabels a cat for a dog, then it adjusts the network a little bit. And so it learns to recognize cats versus dogs. And the more we train it, the more accurate it gets, until at a certain point, it is able to recognize cats as well as humans can do.
Andra, can I turn to you then? Can we take that, which is essentially, I guess I could paraphrase it maybe a little bit crudely by describing it as learning by doing, by learning by making mistakes. And what's the gap between that and genuine intelligence, where a machine learns to think for itself?
Well, I am a techno-optimist, but I do think that there's some fundamental issues with what we currently call artificial intelligence. And I think we actually ought to call it artificial stupidity, because we anthropomorphize the term intelligence far too readily, and that means that we kind of believe some of the excessive hype around what systems are capable of. So to use the cat and dog example, yes, you can recognize a cat or you can recognize a dog, but you can't actually tell if the cat is chasing the dog or the dog is chasing the cat. And that's the sort of really important context that we don't yet have working with what I still call artificial stupidity.
Jürgen, do you want to get in on that?
Yeah, yeah. Anna described something which is called a feed-forward network, which is a very useful device which you can use to tell dogs from cats, for example. In comes a pattern, could be a dog, could be a cat, and then there are these layers and it's moving through, the information is moving through, and it comes out there in the output layer, and there's the classification, and that was it. And it's true what you say, then you can't really tell, does the cat follow the dog or the other way around? But there are more general devices. There are these recurrent networks which have feedback connections, such that you don't have this obvious layer structure any longer. And suddenly, through these feedback connections, these networks become general purpose computers. And they can compute any program that your laptop can compute. And suddenly, anything that is computable can be implemented on these machines. For example, you can feed in not only images, but also movies, sequences of images. And then you can teach it to answer questions such as, does the cat follow the dog or the other way around? It can do that because it's a general purpose computer which does parallel operations, but then at the same time sequential operations. And anything that's computable, any computable way of distinguishing dogs pursuing cats from cats pursuing dogs is possible and can indeed be learned. So if you want to build a general purpose AI, then you need something like that, a general purpose computing substrate. And in our case, in machine learning, mostly a recurrent network and mostly something called a long short-term memory, an LSTM.
Well,
yeah, so I would also want to say, I mean, the cat and dog example is very nice to start explaining the very basic concepts, but I think we shouldn't be fooled by that. You know, we can go much, much further. So for instance, if you're interested in understanding activity, right, activity recognition of like what people do, like you have a surveillance camera and then you want to really interpret whole scenes and understanding of what goes on, there's been, you know, we made tremendous progress there. And that is totally within reach. We might not like all the consequences of that, right? I'm not optimistic that it only leads to good consequences, but the capabilities are there. Or think about the medical context, right? Where, like, you have a machine, it's not so much about cats and dogs, but you look maybe at a histological, you know, cells and whatnot, and you want to make a prediction about, you know, whether a certain type of cancer is going to be dangerous or not, what the right therapy is, and so on and so forth. And what we see is that humans have been able, right, to maybe mark a few right, features in such images, and then other doctors can go in and find these same features. But we don't know whether they're not hidden other interesting features that are in there that can be super predictive. And in the last couple of years, we've seen that there is, right? There's a lot of hidden knowledge, and it's not just about cats and dogs. We're all pretty comfortable with that. But there's things, right, that we can discover through, and that's why also I would like to call it intelligence, and I really don't think we should call it stupidity. We should get rid of artificial and talk about machine intelligence, is my view. But there's, you know, we shouldn't take these toy examples and overgeneralize it too much, because then we miss all the excitement and the really interesting things that we can do.
Pascal, you want to jump in?
Yeah, just quickly, because you talked about cats. When you need millions of pictures in order to say it's a cat or a horse or a cow, to me that is not so intelligent. I mean, whenever I read big data and deep learning and intelligence, it's a little bit, it gives me like a strange feeling, because when I look at children, they look at one cat, kind of cuddle the cat a little bit, and they know once and for all what a cat is. And also another interesting analogy is that people think in the brain there is a computer. We talk about general purpose engines and saying when we are there we have cracked intelligence. I mean, a few hundred years ago people thought there are pumps and wheels in the brain. Today it's computers. I would challenge that a little bit, that the brain is just like a fast or a slow computer.
Anna, you want to jump in as well?
I think
And
one.
I think Anna wanted to say something.
Yeah, you look here. It's
Yeah,
very
sorry.
hard.
I think the field itself is in a very nascent phase right now. It's indeed true that we can recognize cats and dogs and different breeds of cats, probably more than any regular human would be able to recognize and know. But what's missing right now in the field is kind of common sense understanding of the world. If compared to a 4-year-old child, it's the machine that is able to recognize all these different breeds of cats still doesn't know that cats are fluffy, that they meow, and certain things that, again, a toddler just grasps within a moment. And this is learning through experience. This is what this narrow AI that we have right now is not capable of doing, and it's not anywhere close to it.
So Jürgen, how, I know you have something you want to say, but as part of that, how far do we have to go in terms of, if you look at the research, if you look at what's going on right now, how far are we from that common sense AI as opposed to this more stricter, narrower definition that Anna was just talking about?
Let me narrow the question down to an answer to what Pascal said. So he complained, and maybe everybody can follow that. He complained that kids can see a cat and immediately one-shot learning, they know what is this cat thing and so on. And it seems to be really different from what the neural networks, the artificial neural networks do. But it's not at all different, because we can have exactly the same effect by just doing what kids really have done before they learned quickly to recognize a cat. They have seen billions and billions of images through the years they were exposed to the real world, and from that they learn so much about vision. We can do the same thing by just training one particular neural network on lots of different image databases, and then we freeze it and just take the top layer and very, very quickly, in almost one-shot fashion, retrain it to recognize a new data set, for example, the cats or whatever it is, and it's in a certain sense, the system is learning to learn new things more quickly just by being exposed to lots of previous data, just like kids were exposed to lots of previous data before they were able to do that. Now, you had a more general question, which was, can you repeat the question again?
How far are we from, I mean, I think you probably have a very clear view on this, but how far are we from this common sense intelligence? So I'll give you, I guess, or how far are we from intelligence that has an ethical dimension to it? So, for example, we're going to, in Davos this week, there'll be many panels, many discussions about self-driving cars. And of course, there's a lot of discussion about, and you'll get in as well, don't worry. There's a lot of talk about, can we trust the brain of a self-driving car to make the right moral decision when confronted with a very difficult decision in the middle of a traffic accident, for example? How far are we from that? If that's the way, you probably
as engineers, yeah. So there are these famous examples that philosophers brought up or resurrected trolley experiments where the idea is, okay, here is my accident coming, self-driving car, accident coming. I can have only two options. Either I kill 3 guys over there or 5 guys over there. I have no other option. What should I do? Most humans don't know. What if these 3 guys over there are kids? What if all of the 5 guys over there are old people? Maybe one of them is a presidential candidate. All kinds of consequences of your actions, which you cannot really predict.
Yes.
So there is no superhuman AI that will make the correct, universally acceptable decision there. What does the engineer do? The engineer says, in 99 out of 100 cases, what I have to do is take out the kinetic energy out of the system and brake as hard as I can, flash all my lights that the other cars around me know what's going on. I'm flashing all my lights. I'm braking as hard. I'm very predictable because that's what self-driving cars do. They brake in such a situation. Maybe in 1 out of 100 cases, it's not the right thing to do, but in 99 cases, it's exactly the right thing to do. And that's why, on average, the number of deaths per day is going to go down, maybe from 10 dead people per day per 100 million inhabitants down to 1 dead person per day. And so statistically, it will be so convincing that that lawmakers at some point are going to make it mandatory. So the engineer doesn't care for the trolley experiment. He doesn't care for resurrected arguments of philosophy from which have been dead for decades or so. Yeah.
Andrew, you wanted to get in on the common sense
Well,
intelligence
actually,
question.
Jürgen answered that very well,
Yeah.
because I hate the trolley problem. Most people are equally split in their answers. And I think if we look at something like airbags, we don't ask whether airbags, what side of the trolley problem they fall into. We've accepted them as an incremental safety improvement, which nonetheless causes injuries to some people, more so than if they weren't in the car. But we've accepted that the majority of cases, there's a significant improvement. And one of the things that automakers do stress is that the saving of life with self-driving cars needs to be at least 10 times greater than the human decision-making process, because otherwise we will not find that acceptable. So there's this very small space where self-driving car makes the same mistake as people, and then there's that slightly other case where it makes a mistake that no person would. And for us to deal with that as a society, the value of having self-driving cars needs to be fairly well proven as far better than manual driving.
Thomas Hoffmann, you wanted to get in on that?
Yeah, so now we're already on the ethical question, so we're
moving very fast.
Quite a bit. So I think I'm also not a big fan of the trolley problems, all these things, but I think the discussion usually is completely misled, but something other interesting emerges. What emerges for me is that we want to treat algorithmic decision makers and human decision makers differently as a start, because if we didn't, then we wouldn't have to think about that, as Jürgen also said, right? We don't know how humans will actually behave in that situation, and because humans have limited computational capabilities, reaction times, and whatnot, we've never written it down in law. It's not codified what there is to do, because humans couldn't follow it anyway, and we don't want like total precision. Now we get algorithms, we say, wait a minute, this is an algorithm, right? We could tell this algorithm what to do more precisely, and what we find is that we find it very difficult to agree on what we should teach the algorithm, right? Should it evade a mouse? Should it evade a rat? Different types of animals, what should it do? This has nothing to do with AI. It has nothing to do, in a way, with machine ethics. It has to do with the fact that we haven't thought about these problems, because so far they haven't just been relevant problems to us, and now they are, right?
Because we have a social system where a person is held accountable, and then they go through a criminal proceedings or a civil proceedings.
Right, but we could at least we have two ways, right? We could say we treat machines pretty much like humans, and then they would need to take on some form of responsibility. But essentially, we would be happy if, in the large, they do a good job. Or we say we want more scrutiny, which is also totally possible. But then we need to sit down and agree and codify what we want it to be. And I think the problem then is not only an ethical problem, but it's a problem of law, right? The rules that govern, for instance, our individual traffic are already fairly complicated. And for sure, they will get 10 times, 100 times more complicated if we have to spell out every little detail of how we want it. So I think there are problems in the use of AI, but they are not like what people usually think they are, right?
We're going to get onto the politics and the cultural aspects of this later on. But Pascal, what do you say to that?
Speaking for them, when we talk about ethics and AI, to me it sounds a bit like cheating. Isn't it just like the human intelligence of a programmer that you put into source code, and this guy then someone needs to solve the trolley problem? Isn't most AI today nothing else that tint human ingenuity pressed into source code? I think that's an interesting question. Also, like a belt that we have in the car saved also millions of people in car accidents. Do we call the belt AI, although it contains a lot of human intelligence? So I think talking about ethics is a little bit exaggerated here, because at the end it's just the intelligence of a human being in a source code.
Anna Ukunova, you wanted to get in?
No.
Anna first and then...
No.
Thomas.
Okay, I would like to comment about ethics in general. We care a lot about how technology affects people's lives, and there are a lot of difficult questions that appear here. And how do we ensure that applications of AI and machine learning works well for everyone? How do we define fairness? How do we measure fairness in those applications? How do we combat bias? Those are all the questions that are on top of the minds of researchers this day. And there is a lot of hard work for us to do. We need to acknowledge this. We are sharing best practices on how to make sure that we proceed with the responsible development of machine learning and AI applications and research in those fields. And on the research side, at Google, for example, we started People Plus AI Research Initiative to develop research and tools to ensure that AI works well for everyone. And I think there is a lot of more work that we need to do, and there are a lot of different questions again that appear in this field that we still need to answer. And I think it is important that we own those challenges and we face the solutions of those challenges all together across different research disciplines, across different organizations and institutions.
Do you want to get in?
No, I just had a quick one on the build, right? I mean, it is not the intelligence of the engineer or programmer that goes into the system. In fact, the engineer might not even be able to drive a car. It is really, I call these systems intelligent because they have a life of their own. As we engineers who build these systems, we don't understand them either, right? We have to investigate them afterwards. We have to test them. We have to validate them, right? With the seatbelt, I pretty much have a concept. I might also have to do some tests, right, of what the material is and so on and so forth. But the autonomy that these systems have that we build as intelligence systems is far larger, right? And also we work in teams of hundreds of engineers. So it is not that we copy human intelligence simply into the machine intelligence. Something new comes together there. Whether we want to call it intelligence, I'm totally open up, for that, but it has a life of its own. It is very complex. It's very hard to understand. That's why, in order to get transparency into these things, is a non-trivial thing. But I don't think we should think of it as copying human intelligence into kind of an algorithm.
And I think one important thing about machine intelligence, or machine learning in particular, is that right now it's only as good as the data that we provide to the system. And so maybe for us as a humanity, it's also an important moment to kind of reevaluate what our values are and think about them at a bigger scale, and maybe also be a bit critical about our own values, our own biases, and kind of address the problem from that perspective as well.
Andrea?
Yes, I want to follow on with the seatbelt example, because that's actually an example that I use a lot when we talk about the biases of systems, particularly once data becomes embodied physically. Perhaps many people here are already aware that the seatbelts were designed on crash test dummies that were built around the 50% male percentile for American Army men. So they are a lot larger than most other people. And it turns out that seatbelts actually cause more injuries, particularly in softer collisions, to women, to Italian men, and to Vietnamese men, because they are all substantially smaller in frame. And this has been known since the 70s or 80s, but because the regulations require that seatbelts are tested on the approved crash test dummies, I think it's not until 2012, 2013, that car manufacturers have had the kind of regulatory pressure to test on something other than the 50+ percentile white male crash test dummy. And this is exactly where robotics eventually and AI is in the meantime. When you put biased data in, it takes a very, very long time to clean up the mess that you make.
So moving the conversation a little bit into the political realm, I mean, what the consensus of the panel, seems to be is that, you don't blame the AI, don't blame the brain. If, let's say you have a car crash, that particular example, don't blame the AI, blame the inputs that humans put into it. Do we think that, looking at society, looking at the political debate right now, that society will accept that?
We've accepted...
Because we're talking about what I'm getting at here is that there is still this sort of deep concern, worry, suspicion in human society about AI, and the popular culture is full of robots that go badly wrong.
True, but we love convenience, and
right.
every year we've accepted incremental advances on self-driving technologies in our vehicles, from ABS brake systems to self-parking to a whole lot of other features, lane adjust, and because each one is happening incrementally and it's fitting into the engineering product process where it's tested enough to be considered reliable. And I think that that is actually how self-driving vehicles will progress into society, by proving that, in 99% of cases, the self-driving braking will brake 3 times faster than a human would, and we consider that to be acceptable. And we won't then be focused on who it braked for, because it braked as best as a car system could, and we have approved that in production.
So that's a very rationalistic engineer's view on it. Does the rest of the panel share that optimism?
I think the question is one of the key questions is trust. Right? Mm-hmm. And if new technology comes along and we don't know it, we don't know exactly how it works, we don't know how well it works, we don't know actually who has even maybe built it, how can we trust it? It is very natural not to trust it. Now, there's 2 ways to overcome trust, or to build up trust. One is to look for analogies. Okay, maybe this thing is similar like a taxi driver. Okay, I also trust a taxi driver that he drives me, but sometimes I'm also worried, and then I start playing this game. The other is, over time, right, we will just see from experience, collectively as a society, that certain things will work and others might not work. But the things that will work, we will learn to accept, and we will trust them, right? And maybe today we feel awkward sitting in the car and I can't touch, right, the steering wheel, and it's all strange. But there will be a generation where this is totally normal. There's no fear, there's nothing, right? That's just what they raise up with, maybe. So I think that doesn't mean that everything that we could do with AI necessarily needs to be done and should be done and so on and so forth. But there's this issue of trust. And I think in part it will just take time. And I think it's important to educate the public by taking them away. I think Jürgen, for instance, did this, right? If we can reduce the death toll in traffic by 90%, right? Then this trolley problem discussion is maybe not the most material thing to talk about. But we've achieved something really tremendous, right? We've saved that many lives. And I think today we're at a point where we don't see the savings yet, right? Because they are abstract and mathematical, but the worries are already concrete. We already imagine these situations. So I think collectively, our society, we need to, over the years, just make progress, keep discussing these things, right? But we also need the right rules. We cannot just put these things into the wild, But I think it's just a very natural progression.
I was interested to read, when I was researching this panel, Microsoft is coming out with